So let's get started. Everybody ready? Okay. So this is a talk on the new features in the LAN drivers and PE driver for x86. So there's been a lot of changes from Itanium to x86, and this describes some of them. So I'll be talking, and I've been working on VMS LAN drivers for many years. And then Tim and I worked in Bolton on LAN drivers, and he's now in support.
Yeah.
So he'll be doing some of the slides, I'll be doing some of them. So the agenda, first for LAN, the new devices, then we'll go over bandwidth monitoring, which is new to x86. Then LAN tracing, there are a bunch of improvements, mostly user-friendly improvements. Then LAN device special functions. These are things used for debug or fault insertion, but they're useful in a lot of different ways, so we'll go over some of those. Also, some LAN tools that ship on the kit these days. They ship on the x86 kit. Also, some updates to LAN CP, and then I'll go over the PE driver, 64-bit counters, and snapshot functionality. So who would care about this? I don't know, system managers maybe, support people. The LAN tracing is a lot easier to use now than it used to be. And then if any system managers, set up test systems and want to try out some things, make sure their LAN drivers are doing error handling correctly. They can do fault insertion to do that. For example, if you set up a LAN failover set, you want to make sure that you can fail over from one device to another. You can use some of these functions. So I'll have Tim go over the new devices here.
Yeah, so these are the new devices that we have in x86. The E1000, the E1000E, an emulated version of the Intel 1 gig driver. And the main difference between those two is the E1000E has its own interrupts, the MSI-X interrupts. And the E1000 shares interrupts with all the other different devices. So the E1000E has the better performance of the two. And then we have the VirtIO driver and VMX-Net 3. VirtIO is part of KVM, and VMX-Net 3 is part of VMware. And those have better performance than the E1000 drivers.
Hey, Tim?
Yeah.
So like with the Virt drivers, we certainly noticed in the disk space that they were substantially better, like when they ordered like 3 or 4 times faster. Can you quantify how much better these Virt drivers are?
Dick might have a better answer.
It's hard to tell because when you do test between two VMs, if the two VMs are on the same host, for example, all of the transfers are going through memory. So it's a little hard to quantify. And then when you're doing between systems, it depends on the network infrastructure. So
okay,
we'll do a much better job of quantifying the performance differences in the future.
It is better to use the Virt drivers. Would there ever be any reason to not use the Virt drivers?
Well, the E1000 drivers have some more debugging functionality. Like we'll go into it on later slides. But like he was saying, you can there's device specific functions that you can use to to test network connectivity and to force link down and things like that.
I think a lot of people might select E1000 just out of habit, because it's the one that's selected by default,
right?
Set up with VM.
Yeah.
So.
And then later, can you tell us if, like on our existing VMs, should we, as we upgrade them, should we be swapping to these that are available, or should we leave them on the old?
Well, the old ones, I have a display on here that shows the old one running at 3.5 gigabits. So it's not like the old ones are going to be really slow and the new ones are going to be really fast. There's really not really too much difference.
Yeah.
It's
for most cases you'd probably be fine with either of the E1000 devices.
Right.
Okay, so anyway, there is bare metal support, but we don't support bare metal in x86. So it's there if somebody really needed it, but it's not available out of the box.
Those data rates, why bother, right?
Right. Yeah. Dick added some LAN flags parameters for dead devices. So you can, when you boot, you could say, I don't want to boot EIA 0. And then you'd put that one bit as part of the LAN flags parameter, and it would know that. It's helpful. It could be helpful, but it's also helpful for us when we're testing things with the network drivers to be able to just say, oh, we don't want this one to boot up next time, instead of going through the interface for VMware, KVM, and having to do it that way. And there's some updated documentation in the counters and functions. The device internal counters, it goes into detail. The device specific functions, like the LAN CP command that's below it. Each device has its own set of device specific functions that you can set, which we'll go into on a later slide. And it's going to be part of vmssoftware.com documentation soon. So,
Jim?
Quick question. Apologies for arriving late. Are you talking about update 2 or update 3?
Most everything is in update 2. There's some things in update 3, some fixes in update 3.
Okay, thank you.
So I would go with update 3 if you have a choice.
okay, Dick's going to go into bandwidth monitoring here.
So bandwidth monitoring is something that started about 15 years ago when we had this customer case where they were losing packets and they couldn't figure out why. And they would look at their switch and the switch would tell them, well, you're at 30% utilization, but they were still losing packets. So naturally, the LAN driver got blamed for it. And it took a long time to figure it out, but basically figured out by doing LAN tracing all the packets, and then calculating the bandwidth that was being used at each point along the way. And we discovered that even though the switch said over a 10-second period, you're only maybe 30% utilized, if you look at it in a 1-second time frame, it was oversubscribed and it was doing multicast packets, and the switch was throwing away multicast packets. So the only way we could see that was by looking at the performance on a very small interval, like a 1-second basis. So what this does, it records all the traffic, transmit and receive packets and bytes, and it's saved in a 32-byte bucket. Each bucket is nominally 1 second. So every second you collect the transmit and receive packets and bytes. It's very simple. You just save that in this bucket along with the starting time of the bucket. So by default, you have 34 minutes worth of data, 2,048 buckets, and that all comes out of S2 space. And so you have 34 minutes worth of data by default. But if you look at the data that you're collecting, if you have 0 data for the 1 second, then you really don't need a separate bucket for that. So what we do is collect all the buckets, all the data in one bucket that has no data. So you might have a period of time of 5 seconds long where the bucket is actually recording 5 seconds worth of data, and there's no data in the bucket because there's no traffic. And that's a particularly significant item, because if you lose cluster connectivity, you really expect some number of background traffic all the time anyway. So you really never expect a 1 second period to have no traffic. So that's why none gets its own bucket. And then we have a threshold value. So if it's less than a certain threshold, then we consider it just background traffic or noise or idle time. So if it's less than the threshold, we accumulate that in the less than threshold bucket. So what you end up having is a set of 1 second buckets, where some of those 1 second buckets cover more than 1 second. So in effect, you can get a recording time much greater than the 34 minutes by default. And if you have no traffic on the wire, you would have a bucket that covered the entire time that the system was booted. So the maximum, just by, and it's also controlled, the size of the bucket is controlled by the LAN flag system parameter. So the maximum you can go with the LAN flags bits 11 through 9.
Can you set the threshold? Is that something?
Oh, you set the threshold also, but if you had a threshold of 0, using the LAN flags with these bits, you can specify up to 7 megabytes per device, and that's 229,000 buckets, and that works out to 64 hours. You can also use a LANCP command. This LANCP set device/bandwidth equal hours, and you can specify up to 1 year, which is 8,760 hours, which uses a fair amount of S2 space. So 1 gigabyte per device maximum. So the threshold default is 10,000 bytes. Anything less than that is considered noise, and it just gets collected in that bucket. And then whenever you get a second that has greater than 10,000 bytes, you would record a new bucket, and that would have the 1 second value for that. So this is all done in the LAN common routines, and it's done for all NICs. You can also turn it off if you really wanted to. And there's no measurable overhead. Naturally, you don't get anything for free. So it does cost between 25 and 35 macro 32 instructions every 1 second. And that is so small that you can't really measure it. But if you really want to, you can turn it off. So some of the displays, you have show config/bandwidth. That would give you the configuration, the list of devices, and a little bit of data concerning how much the bandwidth was seen in the last few seconds. And then config/status, that gives you more bandwidth information. And then show bandwidth gives you the settings, and then show device/bandwidth gives you the actual bandwidth data. To change the settings, you have an LANCP set command. So set device, there's how you would turn it off, /no bandwidth to turn it off. And then you specify the number of hours, and the threshold value. And you can also specify default, and that sets everything back to the default settings. And you can say restart to restart the bandwidth monitoring. You can also extract it from a crash dump. And in SDA, you would extract it to a dump file, and then you can look at it with LANCP, and I'll show an example of that. So who would use this? Well, used by support and looking at customer crash dumps to answer these questions. Oops. What was going on network-wise before the crash? You know, if you have a clue exit or something, you might wonder, well, did you just lose connectivity so you see no packets on the wire? Well, that would show it to you. Or if the network was really busy, congested, you would see that in the bandwidth data also. And this is all described in this PDF file that's on Stockdale Help. And that's soon to be on vmssoftware.com on the documentation website also. So here's an example. There's a bunch of show commands where you can tell it to look at only a certain amount of data starting at a certain time or for the last certain amount of time. So by default, you can say /last, and that's the last 60 seconds. Or you can also say, there are some other qualifiers also that are all described in the documentation. So here's an example. We're looking at the bandwidth for the last 60 seconds. What I did on this, I set up 2 VMs and I configured it to run XX driver, which is a VMS test driver that we use for performance testing. So I ran it for 10 seconds, and I got, oops. And I got that data right there, which is hardly anything. So then I realized that when I looked at the bandwidth data, I realized I hadn't set the target correctly. So then I set the target correctly, and I get the next set of data, the next 10 seconds worth of data. So here I see 3.5 gigabits. This is using EIA, the EI1000, E1000 device. We're doing 3.5 gigabits between two VMs. And we see the 1 second data. We also see a zero period right there, 18 seconds. After I ran the test, I didn't get it set up for the next test until 18 seconds later, so we see that. And we also see, what we see is packets transmitted, packets received, bytes transmitted, bytes received, and the baud rate, which is the megabits per second. Also, there's a code at the end of this thing. So if you had a year's worth of data and you dumped out hundreds of thousands of buckets of data and you wanted to search it, it would be kind of hard to look for anything. So this code on the right-hand side here just says, what kind of traffic it is. So if it's zero traffic, it just says zero. And if it's less than 1 megabyte, 1 megabit, less than 1 megabit, then we have 2 gigabits, 100 megabits, and so forth. So those are all described in the documentation. But if you get a large output file, then you can search for particular spots in the bandwidth monitor buffer. So here's an example of that. Here, I'm just looking for the bandwidth on EIA in the last 60 seconds, and I just want to see the zero entries. So I see 3 of those things. And that's what I had in the previous screen here, the 3 zero entries. And then I'm just looking at those 3. Also, you can do a show device /bandwidth /summary, and that gives you the high points for each interval. So in that period of time that I was doing the bandwidth monitoring, we see that for interval, 1 second interval, we had a high of 3755 megabits. And for any 10-second period within that data, we saw a high point of 34 megabits. And we do 1 minute, 10 minutes, 1 hour, 4 hours. And I think it's 8 hours, 12 hours, and 24 hours. So we get in this particular case, 4 hour, the highest 4 hour period in that entire buffer was just 2 megabits. So naturally, if you have a system under load and get some real activity going, this would make a lot more sense. You could see what the highest 1 hour period is during the day, or the highest 10-minute period, or whatever. So some of the other commands showed config /bandwidth. That shows you the devices that you have, the speed, device name, the uptime, and then the actual traffic that you've seen, and then the highest 1 minute, 10 minutes, 1 hour, 4 hour, 8 hour, 24 hour. It's the highest running bandwidth during that time. And then if you just do a show bandwidth, that just gives you the settings. So here we have, by default, 2048 buckets. And the first bucket is actually reserved for the header. So there's really 1 bucket less, you get 1 bucket less. But it's 0.6 hours minimum, and that's if you had a threshold of 0. And then in this case, the threshold is 10,000 bytes. And we started, the oldest monitor data is here, and the monitoring started here. And since we haven't run longer than the actual size of the buffer, we haven't actually lost anything off the end of the buffer. Now you can also here I had a crash dump and I wanted to extract the bandwidth data out of the crash dump. So I went to SDA. Oops. And did this LAN bandwidth class dump equal bandwidth dot dump, and then which device I wanted. And then what it does, it tells you this is how you look at it. Show device slash bandwidth slash input equal bandwidth dot dump. And then I did that, and we see this bandwidth data. So this is what we would do if we got a crash dump, and we wondered what was the traffic like in the last 20 minutes, or if somebody had actually increased the size of that buffer, we would have seen a lot more. But we get a really good idea of what happened just before the crash. Yes.
Is there like a qualifier like outbreak for CSV?
Yeah, there is.
Thank you.
So you can.
Hey, Dick?
Yep.
Is this x86 only?
It is right now. However, in a recent meeting, the idea was that we might take the LAN CP and LAN ACP changes and backport them to alpha and Itanium. And that would be really nice to do. So I've already done that once, and I did it to IA64 and sent it to a customer actually. But so it's not a big deal to do it. It's just a matter of getting some qual resources to test it afterwards. So that's the bandwidth stuff. That's the major change in x86 so far.
So yeah, there's been some updates to the LAN tracing. The LAN tracing has been long part of the LAN facility and written into the drivers, but in x86, we wanted to simplify, make it a little bit more user-friendly. And with LAN tracing, one of the big advantages of it is you can look into non-TCP/IP traffic. And so you could take a look into cluster packets, DECnet packets, stuff that you wouldn't get with the TCP dump command. So you can extract the trace data and put it into like Wireshark, or you can read it. Well, yeah, you'd want to use Wireshark for that. And there's
appreciated.
Yeah.
Don't know if it's the right time to ask, but light of the changes coming in future versions discussed yesterday about encrypting cluster traffic, that raises the obvious question of what can be done to make cluster traffic traceable.
Yep.
Yeah.
The moment we go to the encrypted cluster traffic, if it's a small problem, how do you figure out the problem?
Right.
Without having a concomitant problem with exposing the private public keys.
Yeah, we would want to.
I'm not asking for an answer now, I'm just raising it for the record.
Well, that's a good point, because we would want to trace the cluster data in the packet so we could do debugging and so forth. We want to do that before the encryption.
So we're going to need what was previously exposable by using Wireshark, or this not be exposable because it doesn't access the keys.
Right. However, if we trace the data before it gets to the encryption part, then we can do that.
Yes, that's probably the encryption on cluster traffic is probably prior to getting the key, right? I think.
Yeah, those would be some things to iron out there.
Like I said, I'm not asking for on the company, off the company engineering. I'm just saying, raise the flag that will be necessary.
Yeah, that's a good point. Yeah.
Why not? I think that keep flag that says during a troubleshooting session, turn off. That could probably be not allowed by network security. You do that, it's an automatic security requirement. So the answer has to be tracing at a higher level. Otherwise, you can expose, otherwise cluster failure, triggering a cluster failure enables traffic to go on clear on the network.
And also turning off the encryption changes the environment.
That's
Yeah.
true.
Yeah.
I'm thinking of fact, the old trick was force the guy to reset his crypto keys.
Yeah.
And off you go.
Yeah.
So that's an over.
Okay, yeah, so those are some good points. And so here is the trace mask that's used. In this particular case, we have if there's an M there, that means it's part of your mask, your current mask, and there's all sorts of events that you can specify that you want to see in the tracing. Or forks, interrupts, the 1 second timer, which actually runs 4 times a second. So if you really felt the need that you wanted to look to see what was going on with this stuff, you can sort of pick and choose what you want. There's some preset options down here. For instance, PK will give you transmit and receives if you want to just take a look at packet data on the wire. There's a couple other two here that have interrupts, receive done, transmit issue, transmit done. Let's see, any more about that? And there's a whole bunch of different options that you can do there. So these ones over here they're different, right? The different groups of them, are they different types? Or not necessarily?
It's just all 64 bits worth of trace mask. So the first 32 bits is the general purpose LAN tracing, and then
Yeah,
the other half is the device specific.
device specific, yeah. Oh, and there's also a stop mask you can use. So if you wanted it to trace up until a certain event happens, then you could put that in your stop mask, and you could trace until I get a receive done and go about tracing that way as well. So here is a little example of using the tracing. What we do is set the tracing to the packet. So you're going to take a look at receives and transmits, packet data on the wire. So we do a device specific call to the driver, which is going to send these sysI for sysID messages. And in VMS, it sends every 8 to 12 minutes. VMS is going to send 2 packets out on the wire saying this is who I am, sort of a communication mechanism. And so here's where we force that and then take a look at what's going on through the tracing. So then we show the tracing. And here, there were a couple of receives that happened. This is the times in, I think, microseconds since boot, or microseconds times 10. Some pretty small increment of time, but that's the time since boot. This is the delta. So this is our first entry, so it's 0. This is the wall clock time, the actual time. What type of entry it was. Receive. What is this number right here again? Receive one.
That's the number of receive buffers that the device.
Oh, right. That's the number of receive buffers. And by the time we do another receive, it's back there because it's already been processed. The ring index, which part of the receive ring and the driver it was in, the length of the packet. This one wasn't a VLAN tag, so there's no tagging. And here's our VCRP address, the structure that facilitates transmit packets on the out onto the wire. And then here's our source address. No, sorry, this is our destination address, our source address. The protocol, this is an IP packet. And you can see that in the packet data here. If you go from right to left, you see all the Fs and then these bits here. And then you start seeing your packet data afterwards. And then if we take a look, these are the 2 transmits that were caused by this call here, the sysID call. you see them in the tracing, they occur here. First transmit, second transmit, and all that information. And then here you can see that this is the name of this particular node, and you can see it shows that it's x86. So just some very basic information that it's sent out about itself, but this is where you see that in the tracing. And then here is an example of what it looks like in Wireshark. And again, this is handy because otherwise you'd only be able to see TCP data, but here we can see, here's our two packets that were sent, in Wireshark, and take a closer look. And you can pick, like we said, all these different kinds of events that happen with the LAN driver. And then here in Wireshark, it will show you the different kind of events and when they happen. And that was a somewhat new feature that was added to it for a lot of those different ones. And here's the LAN CP command if you wanted to create a PCAP. There's a /PCAP qualifier that you can use. LAN device special functions. These existed before x86. These have been around for a while. There's a few new ones that have been added for x86. This notion of a dead driver, so we can just have it not come up, but not have to go and take it out through the web interface. Alive. These ones are these are for the E1000 drivers only, and these are so that you can test. Like, say you wanted to test what happens if this NIC goes down for a particular period of time, or you could test that out on a test cluster, see how it would behave before going into, a production cluster and having something happen. It's a good way to test what, for network faults. These fault insertion LAN device specific functions. You can make it corrupt packets, you can make it lose packets, you can make it schedule forks, you can do all kinds of things that might be useful to test. And again, there's more information about this in LAN counters and functions, x86 PDF, and soon to be part of the documentation on the website. I'm going to do LAN tools.
So one thing about that last item, SMTU, that allows you to take a jumbo configuration, network configuration, and change the MTU out from under the applications and see what happens. So I've been using that recently to look at PE driver, what happens when it's running jumbo frames and then the MTU changes. Jim?
When you mark a physical NIC as dead or tell it to stop, will that trigger an LL driver failover?
Yeah, it would. Whenever the link goes down, it would trigger a LAN failover driver failover.
Right, so there's a good use for it right there to test out your failover devices.
And some of the other things here, like you can tell it to do no unicast transmits, no multicast transmits, no unicast receive, or no multicast receive. So you can block transmits and receives. So that was only put into the E1000, E1000E because I was too lazy to put it in the other drivers.
Someday.
I really only needed it for one driver anyway. Jim?
How soon can you turn this stuff on? Like, how much of this can you get during, say, the initial boot and cluster formation?
Well, LAN ACP is run very early, before PE driver starts up. So a lot of those settings can be set at that time.
But if the system is coming up and it's just waiting to form or join a cluster, how much of this could you have preset for that? So you could watch the entire cluster come up?
Yeah, realistically, you don't only set one device specific function for booting purposes.
I was actually referring to the tracing that you had earlier.
Oh, all of that tracing starts when the LAN driver starts up. So you can override that with LAN CP so that before the LAN driver starts up.
Yeah, but the question is, how do you do that when the console has just come alive? It says like waiting to form or join the VMS cluster,
Well, it has to get as far as loading the LAN driver.
right?
So as long as LAN ACP is, as long as the LAN drivers are configured
Right.
and LAN ACP
I
starts
guess
up,
my question is, can you set some of these things in sysgen parameters so that it starts up right away? when the driver starts?
Or in driver database, or in the names, or
yes, in the LAN,
Or in
the LAN ACP
It
database.
has to, you need to define here.
Yeah, you need to do the define.
Has to be the way it is.
Is that something you can do now, or is that something?
Yeah, that's
you might
something
have to
that
think about?
Can do for a long time. You can do that for a long time for x86 and IA64 and alpha. You can do that when LAN ACP starts up. So then some LAN tools. These have been around for a long time, but in x86 we started putting them on sysdollar help or sysdollar examples, XXQIO, TCP, and UDP. So XXQIO, you can send and receive packets by QIO, and the prefix XX comes from the LAN test driver. It's now called sysdollar LAN VCI test, but it used to be called XX driver just because device names or driver names were limited to 2 characters. So we called that test driver XX driver. And the name is stuck even though the name of the driver is really sysdollar LAN VCI test. Anyway, so that carried over into these 3 utilities. And those are on sysdollar examples, and you can build it and modify it as you wish. But this is just a useful thing, a debug tool that we use all the time.
Yeah, we use these a lot. Very helpful.
And the build instructions at the beginning of the C source files. And that's just for general purpose use. Okay.
So updates to LAN CP. Again, we wanted to make it more user friendly for x86. So attempts to clean up the user interface, the added bandwidth commands, updated tracing commands. There's a series of LAN CP show commands that have been added: list failover, /list bandwidth, /list trace, /list DLL, and test. And this will sort of give you an overview of all your devices and what their different settings are. Or before you had to just sort of look per device. Improved error handling and updated help. So
let me
just
just
going to go into PED
Just
driver.
one of these commands here. Show the show commands. LAN CP shows something about it. Just an example right here. See. That one right here. Show bandwidth. It just lists all the bandwidth settings for all the devices. And same with failover. It'll list all the failover devices and all the other commands. DLL, for example, all the DLL settings. So it's just rather than do show device, show device /failover to try to figure out which devices are running failover. You can do this just show failover, and that will give you the summary of all the devices. Okay, PE driver, 64-bit counters. So
It's PED drivers and fans in that.
the PE driver had all these 32-bit counters and 16-bit counters. And of course, you could overrun the counters in just a few hours. So most counters are promoted to quad word, and others from word to long word. And also most errors and events also record the timestamp for the last 4 of these things, except for ECS transitions. ECS transitions record the last 32 occurrences. So when you do an SCACP show command, like show bus or show IP or show channel or show VC, you can also specify /timestamp, and that will include the timestamps for any of the errors or events. So for each one of these things, not only do we increment the counter when one of these events happens, but we also have a clear counter value. So, well, let me first go through this part of it here. So if the counters exceed the field width, the counter would be reduced, and a K, M, or G, or T would be listed at the end of the counter, just so that the counter value fits inside the field. So that's just done as needed. But Keith had mentioned that, in fact, you might want to see all of the data. So if you disregarded the formatting, you didn't care what the formatting was, there'll be another qualifier /byte that will not abbreviate the counters. And that way, if you're parsing the output, then you can get the entire counter value. And also, the PE formatting is the same as SCACP. So the interval counters implementation has changed. So when you do a show something with a /snapshot, that saves a snapshot of all the counters for all the buses, channels, and VCs. And then when you do show something like show channel /something, it'll show the counters since the channel was created. But if you do /interval, you'll do the counters since the last snapshot. So basically you get interval counters. And you can do, for example, you can use this to do the snapshot every midnight, for example, and then every time you do a show channel /interval the next day, it would show the counter since midnight. But it's just useful if the counters are getting so big that it's hard to parse them, hard to really follow them on the screen. So here's an example.
You're like 5 minutes over, so to kind of wrap it up for you.
Oh, okay. So here's an example. Show channel /snapshot, and then wait a bit, and then if you, the first screen here just shows the actual counter values, and then /interval shows the smaller values because we're only looking for the 3 minutes and 48 seconds. So that's an example. And that's it.
All right.
Any questions?
In PE driver, right now, PE driver favors LAN circuits over IPCI circuits. And it does that using a little hack. When it gets done setting up the IP channel, before it returns, it subtracts 2 bytes from the channel size. So when a PE driver takes a look at what channels they use, it's going to use the ones that have the larger transfer size, which right now are the LAN drivers. There was a LAN CP command, I think, to change that, but it was no opt in the driver. You remember?
No, there was actually a change made by India for Flex 10 support and allowing a 16-byte difference between IP channels and LAN channels. So now what I've done is I've added a PE 3-bit that says make IP channels and LAN channels equivalent with respect to size. So that way it won't favor one or the other. It'll actually depend on the delay values.
Nice.
Any other questions?
That, you don't know how long that's bothered me.
It bothers me too, so. Okay, thank you.
Thank you, everyone.